To find unexplored solutions to complex engineering challenges, sometimes we have to tackle distinctive drives. This is one of those instances where we over-engineered a jigsaw puzzle to demonstrate the intricacies of event sourcing vividly. Welcome to another episode of Fidenz Tech Adventures. In the dynamic world of software development, managing and maintaining an application's state presents significant challenges. Event sourcing, a unique architectural pattern, enters the picture to modernize this process, providing a solid foundation for understanding not just where the system is, but also how it got there, dramatically increasing transparency and traceability. Event sourcing is an architectural technique that records changes in an entity's state via a chronological sequence of events. This technique differs from standard approaches in that it emphasizes the chain of events that led to that state rather than the current state itself. Here are some basic event sourcing notions that we will demonstrate in our project. An event represents a fact or assertion about something that occurred in the system. It provides all of the information required to describe the event, usually in an immutable manner. Events are arranged into an event stream, which is an ordered series of all state changes for a single entity throughout time. Event handlers are important bits of code responsible for processing and reacting to specific events, defining the system's response to each state change. Event Store is a specialized storage system built for storing and retrieving such events. Benefits of event sourcing: immutable event log, event replay, auditability and traceability, consistency and eventual consistency, improved scalability and parallelism, fault tolerance and disaster recovery, support for event-driven architectures. Project overview. We employ a simple and entertaining example. This single-player game is designed to demonstrate the principles and benefits of event sourcing and event-driven architectures by having the user interact with a web interface to assemble a jigsaw puzzle. In this game, assembling a jigsaw puzzle is viewed as an entity whose state is defined by the events that occur during the assembly process. These events describe the actions taken to complete the puzzle, such as starting the game and adding or removing pieces. Implementing event sourcing in Jigsaw puzzle game. This application has been intentionally over-engineered to effectively illustrate event sourcing capabilities. Entity. The Jigsaw puzzle game entity is designed to represent the current state of a gaming session. This encapsulates the game logic and helps validating events for an ongoing gaming session. Event. Each game action triggering an event sent from the front end to the back end, such as game started event, piece added event, and piece removed event. This facilitates real-time game interactions and state management. Event stream. A gaming session begins with a start game event, marking the commencement of an event stream. Subsequent events, including piece added and piece removed events, will be sequentially numbered in chronological order. This ensures ordered, reliable processing of game actions. Event handlers. Event handlers are designed to react to various events, taking actions such as processing data and updating Jigsaw puzzle game entity. This process enables dynamic game state management based on player actions. Event store. Events are stored in the event store and can be retrieved as needed. Once saved, these events are immutable. Each event record includes essential information such as the unique game session ID, event type, event stream ID, and event data, among other details. This provides durability and historical tracking of game actions. Immutable event log. Event store implementation provide chronologically ordered immutable events of a gaming session, which ensures accurate tracking of puzzle progress. Event replay. With the event list, a player can go back to a certain point in the game. This can be done by selecting an event from the event list. The system then reverses all subsequent events by applying their opposite, restoring the puzzle to its desired state. This gives the ability to reverse the puzzle state and understand puzzle assembly. Consistency and eventual consistency. Storing events is done in chronological order with event stream ID and event type. This distinguishes between the various events that occur within a gaming session. The architecture of the Jigsaw puzzle game exhibits scalability and asynchronous processing, using an event-driven approach aided by Kafka. The application is separated into two parts: a front-end application, which provides the user interface for games, and a back-end system, which includes 4 different services. Let's take a look at each of the services and their respective roles in this architecture. Front-end interfaces with the user, sending game events to the API service. API service relays events between the front end and back end. Aggregate process and validate incoming events. DB writer saves events in the event store. Projection applies further processing and filtering to events and generates response events. Independent service scalability is a key feature of this architecture, where each component can be scaled based on its specific demands. This targeted scaling approach is more resource efficient than scaling a monolithic structure, allowing for a more nuanced response to changing load patterns. This Jigsaw puzzle game effectively demonstrates event sourcing principles, showcasing how each action contributes to the puzzle's state. This highlights the power and potential of event sourcing in software development. As technology progresses, the evolving landscape presents an intriguing prospect of how event sourcing will influence the future of data management and application design. For more exciting tech insights and hands-on experiences, check out how we crafted a robust on-premise Kubernetes cluster on bare metal devices. Also, don't miss the process we followed to create a relational and non-relational data synchronization app using Kafka. Find the links in the description below. Stay tuned to Fidenz for more updates. Happy exploring!